Another problem that comes across quite sometimes with archive films is the vinegar syndrome. So vinegar syndrome, this is not a film with vinegar syndrome, by the way, but this was the only film that I had when I had to shoot this photo. So vinegar syndrome is usually very banded, very soft, very sloppy. So this can fall off the wind very easily. In order to prevent this, we have invented this high-tech method to hold back the film, prevent to fall off. But again, this was like many of the other things that were feedback that we gathered from our customers and said, you see, this problem can occur. How can we deal with it? And if ever possible, we will react. Also in the future, we will react to that and try to find a solution. Another very well-known problem is faded colors. So usually the cyan dye goes away very nicely, and with no correction or with just minimum correction for the levels, you achieve this kind of image straight off the scanner. But with using the RGB light control, that light control means no electronic gate, but really we control the amount of light that is hitting the film. And with the individual control of the dynamic range of each of the three colors, we fairly easily achieve these results. And this is not doing some sophisticated color correction or anything else. This is just light control and density range control. Another thing that is important is to detect dirt and scratches. So if you look at this film very precisely, you see here is some dirt on the film. Also, there's a little nice spot. I can magnify that area, and you see here, it looks ugly, and this one as well. So the dirt mat, which we create in the machine using infrared light, results in this image. So we have RGB and a fourth channel, with it is the alpha channel, where we put the dirt mat into. So this is the dirt mat of that image. You see, we detected this big one and the small one here, going back to the image here and here. You see that. But we also have not just the detection of the dirt and providing the dirt mat for use in a downstream system, such as Flexity, but also HSArt or PF Clean. We can use a certain amount of correction on the scanner itself while we scan the film. So, and this is how the film looks like if we switch on that dirt concealment. This is not a restoration. That means we can conceal small dirt and scratches. If there are big blotches, we still need to have a restoration tool. But most of the dirt is the small ones, and they are cumbersome to repair. So if you have a tool which is working very precisely, that means there cannot be a misdetection because it's optically detected, and we can do the repair on the fly, you have a much less work to do and a much smoother workflow. No, this is simply working on negative and positive color film. Black and white film, that does not work because the emulsion on the black and white films contains silver, and silver is not transparent, unfortunately, to infrared light. Another thing that we can do in the scanner itself, but which requires a second step in processing, which we call the batch processing, is grain reduction. So film can be very grainy, and if you have a close look to that area, you see all the film grain, which is, the higher the resolution is, 4K or so, the more obvious the film grain becomes, because the content usually is much less in resolution compared to the film grain. So what we also can provide in the machine is a grain reduction in batch processing, and you see the before and after quite nicely. Sensitive base material, especially nitrate films like this one here, we can safely transport this film. There are no higher temperatures. We have a low power light source. We have even provisions for shuttling these films not beyond a certain speed that can be set by the operator. So we are very safe in scanning nitrate films. But there is always a risk in handling nitrate films. Even if you don't put it on the scanner, there's always a certain remaining risk. But usually nitrate films that can be scanned can be easily put on the Scanity to be scanned. Here, by the way, you see another example of an attempt to repair it. So there were some perf holes missing. This film, by the way, came from a customer in Poland. And they simply repaired it by putting some sticky tape over it without punching the holes. Other scanners with using pins would not be able to scan that part of the film. This part runs through the Scanity very easily. No, you even don't notice it. Then what is also quite unique for a scanner is that we can scan the optical audio tracks from 35 and 60 millimeter film, as well as 60 millimeter audio tracks from 60 millimeter film. Magnetic audio tracks from 60 millimeter film. This is the audio scanning unit, and you see we simply loop the films through here instead of going straight through here, and scan the audio, and we scan in 2K mode. We can scan in real time, 24 or 25 frames per second, and therefore we have a continuous transport, no intermittent transport, and therefore we scan the audio together with the film, creating broadcast WAV files out of the analog tracks, and put it in a separate path and parallel to the DPX files that we get from the images. Another thing that is also coming as a feedback from customer is the overscan mode. So you see here we can see parts of the image left and right, so you already see the perforation holes. And we can scan parts of the image beyond the frame bar. And very much in contrast to other scanning systems, we simply adding more pixels to the left and the right and more lines on top of bottom. That means very much in contrast to optical zooming or digital zooming into the image, the resolution per inch or per centimeter remains the same and remains high. It does not go down. So if you scan with more lines and more pixels, and you usually do a image stabilization, then in a downstream system, and then crop the images, and then you see that here you remain after cropping. This is the blue border here. You remain with 4096 times 3112 lines for the pixel without having the losses due to zooming digitally or optically. Well, that's pretty much what I wanted to show you. Yeah. We have one of the breakout sessions is on the Scanity. I can give you a little overview within 20 minutes that I have, or 25 minutes that I have, how to operate the machine. And you will see that operating the machine is much easier than you may think if you think a telecine is. But still having lots of these nice features, which are continuous transport, real-time scanning in 2K, very fast, very easy process. Okay. Thank you very much.
Thank you, Michael. Thank you very much.